Okay, today we are doing Math 2, Day 2 notes. We are going to be talking about transformations. So anytime you're transforming or translating something, it's going to be your original shape, and then this is the prime shape. Okay, so this is saying like L prime, M prime, N prime. This is telling you that it is translating. Okay, so whenever you see T with something like this, they're translating it. And this is how they are translating with the X, and this is how they are translating with the Y. Okay, remember that X goes right and left, and Y goes up and down. Another way to think of it is you take whatever the X value is, and in this case you would subtract 3 from the X value, or you take whatever the Y value is and you would add 4 to it to give you your new point. So this image has already been graphed for you. Okay, so now we want to graph the prime one. So there's two ways of doing it. So they told us that we are going to go left 3 for -3. In fact, let's talk about this really quick. This is your x-axis and y-axis. Up is positive, down is negative, right is positive, left is negative. Are we all good there? You guys remember that? Okay. So one way is if I were, let's say, to start with L, it tells me to go left 3, so if I go 1, 2, 3 to the left, and then 4 up. 1, 2, 3, 4 up. And that is now my L prime. Okay, now here we need to write that ordered pair, and that ordered pair is at what? Very good. 3, -1. To double check myself, we would take X, the X value, and subtract 3. And is 6 minus 3, 3? Yes. Is -5 and a +4 -1? Yes. And just as a reminder, anytime you have a positive and a negative number, you subtract and take the sign of the bigger number. So with -5 and 4, I'd go 5 minus 4, which is 1, but it's going to be negative because 5 is bigger and 5 is negative. Okay? So in this one, if we want to start by just doing this, we would go 5 minus 3, and what is 5 minus 3? 2. And then -1 plus 4 makes what? 3. Correct? And so if we go for M prime, we go right 2 and up 1, 2, 3. I'm going to double check myself. So remember, from here I would go left 1, 2, 3, and then up 4. 1, 2, 3, 4. So either way, you can double check yourself by going from this one and shifting it, or going and adding the values that they told you. Okay, go ahead and mark N on your own. And check with other people in your group. Make sure you guys agree that you got the correct point. Okay, so what should be your value for N prime? Very good, -2, -1. So again, if I go 1 minus 3, that's -2, -5 plus 4. We subtract, take the sign of the bigger number, and get -1. So when I plot that on the graph, we would go left 2 and down 1, and that is my N prime. Okay, now we'll go ahead and draw this triangle. Okay. The next thing they asked us, it says draw L prime, to draw that segment. Okay? How do I know that that's a segment? A line has arrows going in both directions, right? Since there's no arrows, then this is a segment. Okay? And so from L to L, L prime to L, we have this line right here. Hopefully, I should probably just use this. Okay. So, and then I'm going to do the same thing from M to M and N to N. Okay, one thing I want you to know is that when you have the line versus no line means they're actually talking about the distance. And what do I mean by distance? I mean we're talking about like a specific number. Okay, so this is like talking about the segment where there's, you know, an infinite amount of points on a segment, where this is talking about how long that segment is, the distance of it. Okay, so looking at these lines, what do you think is true about them? What is similar? So talk in your groups. What do you think? What do you notice? So we're looking at these red pieces. What do you notice about them? Okay, so I hear that they all have the same length or same size. So if you look at this as like a three-dimensional shape, notice how like this would be a triangular prism, and all of these are the same lengths. What else do we notice about them? They're the same slope. Good. So they have the same slope, which means that they're all, when they have the same slope, that means they're what? Good, parallel. Okay, we're gonna skip down now to E. And oops, I need to move this back down, sorry. I want you to find the slope of LM. How can I find the slope with doing the least amount of work? What? Good. So remember that our slope is rise over run, or think of it as the change in y over the change in x. Anytime you see that little triangle, it's an abbreviation for change. Okay? So for LM, the easiest way is to count. So the rise value is 1, 2, 3, 4. So that's 4 over, and we go left 1. Good. So that would be -1. So when you reduce that, it is -4. Now I want you to do the same thing on the next one. Oh, sorry, for L prime and M prime. That's what I mean by the next one. What will that slope be? So if you counted, it should have been up 1, 2, 3, 4, and left 1. So we notice that they have the same slope. You guys are so smart. Okay, now you do LN. Anybody know what the slope is of LN? It is 0. Very good. Which means that L prime, N prime is also
0.
Okay, do you guys know the difference between 0 and no slope or undefined slope? How do you guys remember it? Okay, so me personally, how I remember it is I know that like a flat surface, it takes 0 effort to walk on a flat surface. Okay, but if there were like a straight up and down like our wall, there's no way I could just like walk up our wall unless I had superpowers, and I don't. So I remember that the straight up and down one is no slope or undefined because there's no way that I could do it. Where 0 slope is 0 effort, very easy. Okay, all right, you guys do NM now. Okay, so if you counted, what did you get when you counted? Very good, 4 over 4, and that reduces to 1, which means this one will also be 1. So, in translations, the slope of corresponding sides are equal. That is, the corresponding sides will be the same, or we're going to say parallel. Okay, one thing I want to tell you is that if you notice I've made a math error, please stop me and tell me. Anytime you find me making a math error, you get a candy. So, find my errors. Okay, it's very possible it's going to happen. So, okay. Rigid motions. Okay, so rigid motion is a transformation that preserves distance and angle measures, and therefore the pre-image and the image are congruent. What does congruent mean?
Same.
Very good. So if you don't know that, make a note that it means that they are the same or equal. Okay, so they're going to ask us to now reflect this triangle about the x-axis. Which one is the x-axis? The one that has 0 slope. Okay. All right. So in your groups, talk about how you learned or what you think the best way is to reflect something across the x-axis. How would you draw this new shape? So talk in your groups. See what you guys think.
Count how much R goes to the x-axis and just do the same again.
Okay, does anybody want to share out? Do they have the best way? Okay, how do you do it?
Say like X, like you got to go down 3 and stop at x-axis, and then you look down 3 again.
Perfect. I think that is a great method. So if you didn't hear, he just counted down 1, 3, and you stop at the x-axis because that is where you're reflecting across. And since it was 3 to the x-axis, you're going to go down 1, 2, 3, and then we're going to make S prime. So same thing here with the R. So if we count 1, 2, 3, 4, 5, that means I have to go from the x-axis another 5. 1, 2, 3, 4, 5, and that makes R prime. And the T, it was only 1 from the x-axis, so we go down 1 and we make T prime. Do we have questions about what I just did? Does anybody have another method that they use that they want to share? Okay, so then you can use your rulers or your ID cards or whatever you choose, or nothing, and draw your lines. Okay. So let's check this out here. And so R prime, if we figure out this point, what is that value for R prime? -4, -5. Okay, S, what value is that? T? Okay, what do we notice about comparing our X's and our Y's? Okay, so X's stay the same, so whatever X is in the original, when you're reflecting across the X-axis, the X stays the same. And then what happens to the Y? Very good, the Y is negative. So whatever value Y is, it becomes the opposite. So if it was 1, it was -1. If it's 3, it's -3. Okay? All right, and right here where it says how did we decide to reflect it? We did it by counting. You can write whatever you want to here. It's kind of up to you. All right, I'd like you to find the slope of RS. So let's go ahead and count for that. So that's our original figure. So what is my rise value? 2. Over value is, and that reduces to be -1/3, right? Because we can divide the top by 2 and the bottom by 2. 2 divided by 2 is 1. 6 divided by 2, 3. Okay, now let's check out the slope for r prime, s prime. What happened here? The what? So the r went up, okay, so it went rise 2, and then it went right 6, which reduces to, what do you notice about these? They're just opposites. One's positive and one is negative. Okay, so RT, find that slope. You know what? You can count it either way. So as long as there's only one negative. So you could have started from, so you started from R and went down 2 for the negative 2, but then positive 6. So as long as the negative's with one of them, you can count it either way. Okay, RT. What do we get? It should have been 4 over 2, and what does 4 over 2 reduce to? Positive 2. Now you can count this one, but if we use a pattern, if this is 2, this one's going to be a, very good. Yes. So when you're reflecting across the x-axis, it's going to be the opposite. Okay, so slope for TS. Anybody figure that one out yet? Yes. Good. 2 over 8, which reduces to 1 over 4. Is everyone clear? Oops, sorry. On how we are getting these numbers? So we're just starting at one of the points T or S, and then we're figuring out how many up and down goes on the top and how many right and left goes on the bottom. And just you have to remember, if you're going down or left, that's a negative, where if you're going up or right, it's a positive. So if this is 1/4, what will be the slope of the prime? Very good. And so when reflecting across the x-axis, the slope of the corresponding sides are opposite. Okay, and you could do something like, if it's positive, it changes to negative. If it's negative, it changes to positive. Okay, do we have questions here so far? All right, so this next part says, what is RS? The length of RS. Okay, in your groups right now, I want you to talk about, because this is a slanted line. It's not specific on points. How can you find that length? So talk to each other. See what you think. All right, so anybody want to share how they think we can find the length? Okay, what do you think? You could use Pythagorean theorem. The only thing though, because Pythagorean theorem, you want to have like 2 sides and a missing side, right? But if you look at all these, none of them make like a straight up and down line where you have exact units. And so all of these slants, while it looks like this is one unit, it really isn't. Because of the slant, it's maybe more than a unit. Okay, so what's another way? Anybody else have some ideas?
Well, wouldn't you use the Pythagorean theorem by breaking it down like your slope to different points, and then you take those?
Okay.
So you
Let me see this. I just want to show you guys this because this is another really good idea. So you could break up your triangles so you could make straight lines to kind of figure out how you could add them up. That would work. Okay. There's another method though. Anybody have any other ideas? Distance formula. Okay. Your distance formula is probably the easiest. Okay. Now who remembers the distance formula?
I know it's squared d squared x to x1 minus 2.
Okay, so I'm going to write this down a couple ways, okay? So I'm going to start here. We have our distance formula. Now, just because I'm saying that I think this is the best way, if you want to do it a different way and you get the right answer, I'm okay with that, okay? I just usually try to show you guys what I think is easiest. So distance formula is where you have the square root, and it is the change in x squared plus the change in y squared. Now, you might have also seen this like this. x2 minus x1 squared plus y2 minus y1 squared. Okay? Now, both of those are the same. The thing you have to be careful of is whatever 2 points you choose. So let's just do this. Okay. So we need these points for R and S. The nice thing is that they already are given to us right here, correct? So my R, I'm just going to write it here so I have it, is -4, 5. And my S is 2, 3. I also will make a point that I see that these are X's and these are Y's so that I don't mix them up. Whichever X value you start with, you have to make sure you start with the same Y value when you get to the Y part. So what this means is we will take the square root and we are going to subtract the X's. So I'm going to go -4 minus 2 squared plus. So since I started with this point with -4, I have to start with this point with the Y. So that's going to give me 5 minus 3 squared. So I'm going to stop, and if you're confused by something, you can ask me a question now, or if you're just catching up writing. Does anybody have anything they want re-explained? We're okay with all this? Okay, so what's -4 minus 2?
6.
-6. So remember, when you have two numbers that are the same sign, you add them and it stays that sign. Okay? Plus, and what's 5 minus 3? 2. And then what is -6 squared?
36.
And 2 squared is? So I get the square root of 40. And we're just going to leave that as our answer for right now. And you can't see what I wrote, sorry. Okay, and let's check out. Can you guys do the same thing, but now with your prime values to see if the lengths are the same? We're just going to check it out. So you have your prime point values. So that's -4, -5, and 2, -3. Okay, so use your distance formula as well and see if it is the same distance. So you're just using the distance formula again. The numbers are similar, but negatives are in different spots on this one, right? Okay, what did you guys find? It is the same. Okay, so if I take the square root, it's going to be -4 minus 2 squared plus -5 minus a -3 squared. So be careful of those double negatives. What happens when you have two negatives side by side like that? Good, it makes a positive. And so if we continue on here, I have -6 squared. -4 minus 2 is -6. Plus, and -5 plus 3 makes -2 squared. And so we end up with 36 plus 4 again, because when you square negatives, they become positives. And I get the square root of 40. Did some of you mess up on the double negatives and stuff? Yeah. So just be conscious of it and hopefully not make the same mistake. All right, so what do you conclude about this? The lengths of corresponding sides will be Parallel, or we're going to actually say congruent. And congruent means equal or the same. And that's the reason why I'm writing congruent right now is because we're talking about a specific distance, okay, a number. And so we're saying that they're congruent or the same. Does the transformation of a reflection preserve rigid motion? Yes. Okay? And so what that, we're just moving it. Everything is staying the same. We're just moving it somewhere else. So is this triangle congruent to this triangle?
Yes.
Yes. Okay. We're going to stop here for today. You guys are not out of here until 58, right? So we still have some time. We'll have to finish this up later, but I need to pass out your homework.
You have something